There are many ways to solve algebraic equation in MATLAB. Here in this video, we are going to discuss two of them. So let's begin with method number 1. For example, we have this equation 4x plus 7 is equal to 0 and you need to find the roots of this equation. So in method number 1, we do not write this entire equation in MATLAB, but instead of writing equation, what we'll do, we'll represent this equation as a matrix and then we'll find the root of this equation. So now let me show you how to do this. So here we have in our MATLAB, we'll take a new script, CLC. So here the equation is 4x plus 7 is equal to 0. The corresponding matrix is like this, f is equal to 4 and 7. The 7 represents the coefficient of constant and 4 represents the coefficient of x. So to find the roots of f, we'll write roots of f. And now let's run this thing. So the answer is minus 1.750. Let us try another equation. Now instead of the simple equation, we have equation with 3x square minus 4x plus 7. So the corresponding matrix to this would be equal to 7, which is coefficient of constant, then minus 4, which is coefficient of x, and then after x there is x square. So the coefficient of x square is 3. The same way we can go for n numbers of power of x. So here we have this equation and corresponding matrix to this equation is 7 for the constant, then coefficient of x is minus 4. So after x there should be x square, but in our actual equation there is no x square. So what we will do? The coefficient of x square is 0. But in matrix you need to go in this sequence only, constant, then x square, then x cube, then x raised to 4 and so on. Right, so in this manner you need to proceed. So now there is no x square, so coefficient is 0, x cube is minus 5 and x raised to 4 is 2. So now what we'll do, we'll go to MATLAB and solve this equation one by one. So first we'll solve this, f is equal to 3 minus 4 and 7. We'll call it x, roots of x. We do not want these two things, so we'll suppress the output. So here we get two roots of x, the first one and the second one. Here is the real number and the imaginary number. Now we'll go for the third equation. This one. So these are the different possible roots of z. So this is how you can solve the algebraic equation using this roots command. Okay, so now it's time to explore the second method through which we can solve the equations. This method is not limited to algebraic equation. You can solve many equations using this method. So first you need to define variable as a symbol, and for that you need to write syms. Let's say we are defining this y as a symbol, and now we'll write solve. We'll write this equation. Here the equation was 4x plus 7, right? So instead of 4x plus 7, what we'll write is 4y plus 7. This was the equation, and now let unsuppress it, and we do not want to see these things, so suppress it. And now let's run. So here you can see the first answer is of roots of f, and the second answer is from this solution. Now here you can see the answer is in minus 7 by 4 format. If you want to be more precise like this, then you can convert it into double. And there we go. This is your answer, minus 1.7500. Now let's solve another equation, the third one. Now let's implement another equation. Now let's run this thing. So here you can see the both are same. The difference is just in sequence. The rest of the things are same.